Hello everyone, welcome to today's video. Today I'm going to be showing you how to design an inverter using SG3524, the IC I introduced to you earlier. So please, I would recommend you follow this video carefully for better understanding. Now these are the things that you're going to learn, or things that consists of in this video. You have the input filter, you have the oscillator circuit, the driver section, transformer section, output section, and the feedback section. Now quickly, we are going to start with the output section. Sorry, I use a pen to draw it for better understanding. Now the input section, sorry, I made two errors here, and I will want you to follow me carefully as I address them. Now this B positive, this B plus you are seeing is your battery positive. Then this regulator is not 5V regulator, it's 12V regulator. Sorry, it's a mistake. It's supposed to be a 12V regulator, and the capacitors there are 10UF. Both the one before the regulator and the one after the regulator, they are 10UF, 10 microfarad. Now these capacitors are present to smoothen the flow of current while the inverter is inverting. You know, it affects the battery stability. It affects the battery, the pulse that comes up while the inverter is inverting. It affects the battery stability. So the capacitor is meant to maintain that for the IC. And if you notice, there is a key there. You see a cutoff. The cutoff there is for switch. Any kind of switch you'll want to use, on off switch. Then the V positive now will be connected to the IC. It will be the output that will connect to the IC, that will power the IC. So once the switch is cut off, then the whole system is automatically shutting down. So here is a typical oscillator IC, oscillator circuit of SG3524. So I'm going to explain all the pins here and their function, the ones that are selected, sorry, and their function. Now the pin 1, as you can see, sense there. The sense there is for feedback, for voltage correction. So inside of this IC, pin 1 and pin 2 are operational amplifiers. They are used to vary the voltage, the input and output voltage, and to make sure that the output voltage is balanced at 220. That is for 220 volt, and for those 110, you get 110 on standby. Now the function of the feedback is that your battery is 12 volts. So while discharging, your battery will continue to drop from 12 volt, 11 volt to 10 volt. Now if there is no feedback, on the circuit, you will notice that the more the battery is dropping, the more the output voltage is dropping. So in order to maintain the output voltage, that is the essence of the feedback, which is the pin 1. I will show you the circuit for the feedback on the next slide, but for now, this is the oscillator circuit. So the pin 1 is for feedback, then the pin 2 is a reference voltage. I told you it is an operational amplifier. So the reference voltage is referring from the voltage coming from the outside and referring it to the pin. So it will be using the pin 2 to correct the pin 1 voltage. Are we together? Now the pin 3 is an oscillator output. If you are connecting another external oscillator, you want to use it with this same oscillator, then you can use pin 3. Then pin 4 and 5, we are looping it to ground. Pin 4, 5 and 8 will be looped to ground. Then pin 6 and pin 7 are the most one of the most sensitive pins in this IC. Now we are you can replace pin 6, the variable resistor there. You can leave that 470k or 500k, and you adjust it to get your 50 hertz frequency. Now the pin 6 and pin 7 are for frequency, to set frequency of the inverter. If it is 50 hertz or 60 hertz you want, that is where you can get it. So now by the C1, that is the capacitor in pin 7, you replace it with 104. You replace it with 104, or you can call it 100 nanofarad non-polarized capacitor. You can replace it. Is advisable you replace it because these are 556 nanofarad will switch this inverter at a very high frequency to be too high. So you just make it 104. Then for the resistor also, you can quietly adjust it to 140k. That is across pin 6 to ground. You can adjust it to 140k to give you within the range of 50 to 60 hertz. I am very certain of that. I've done the calculation. So it should 140k resistor from pin 6 to ground should give you between 50 to 60 hertz. That is the output frequency. Then pin 9 is compensation pin. The function of this pin 9 is for soft start. Soft start means when you turn on an inverter, it should not just bring light at 220. It should start gradually until it turns up. So every inverter has this soft start. Even the modern inverters you have now, it has this soft start. So that is the function. So if you let's say for example this 10 UF, you decide to put 4.7 UF, the soft start would be faster. Then if you decide to put now on this pin 10, it takes 3 seconds to power this IC fully completely. But if you decide to put like 47 UF, it might take up to 9 seconds or 10 seconds to charge up. So this capacitor here determines when or how long the inverter will take to peak completely. But like this one, as I've told you, is just just 2 seconds. 2 seconds it takes to pick up. Now the pin 10, if you notice, it is connected to ground, but we are not going to connect anything to this pin 10. Yes, don't connect it to ground. We will not be connecting it to ground. We will be connecting it to our battery low circuit, and that will be available in the next video. We'll be connecting it to our battery low circuit. But for testing, for the sake of those that will want to test it after watching this video, you can just connect the pin 10 to ground. That is for testing. So this pin 10, once there is an analog signal of up to 5 volt, an analog signal that is not more than advisable, let it not be more than 5 volt, please. Any signal coming to this pin 10, that so long it is not more than 5 volt, not more than 5 volt and not less than 3 volt. Now once this signal is connected to pin 10, automatically the IC will pause. The pause means it will shut down, but the switch and everything is connected, but the IC will stop oscillating. The oscillator will stop. Every other thing is okay, but the oscillation will, so not immediately that 5 volt is disconnected, immediately it will continue. So we'll be using it for our battery low circuit, so that when your inverter shuts down, then we can be able to, when your battery is low, then we use an operational amplifier to power and signal this pin 10 for a battery low shutdown. Now pin 11 and pin 14 are the oscillator output. Now these two output are supposed to give you 5 volt on each side. If by mistake or by any cause one is given higher than the other, let's say pin 11 is giving you 5 volt and pin 14 is giving you 7 volt, then it means the IC is bad. So each of them, the difference between the two of them should not be more than 0.5 volt. The difference between the two gates should not be more than 0.5 volt. So pin 12 is the collector for the pin 11. Then pin 13 and pin 15 also is the collector for pin 11, because inside of this IC, pin 15 and pin 13 are collectors. It has a transistor inside. That is how it pops the signal out. and give you the 5 volt. Then pin 16 is the reference voltage, coming into the inverter. Now the MOSFETs here, as you can see, they use IRFZ44N. If you check the MOSFETs, the two MOSFET that are here, they use IRFZ44N, but you can decide to use 3205, 3207, IRFP250. So it depends on the capacity of the inverter. Now I will discuss MOSFET too on our next video, MOSFET capacities on our next video. Now these are 11K resistor you see across to the gates from the oscillator output pin 14 and pin 11. The 11K resistor, it is advisable you use either 4.7 ohm, or you use 10 ohm, or you use 47 ohm, or you use 100 ohms. Now you need to use a very low resistance. Why? Because this IC, we did not attach any MOSFET driver on it. So while driving, the MOSFET will drain the current it's having. So this 22K also, the function of this 22K is so that the gate or any ripples from the MOSFET will not be available. There will be no ripples in case, so that the MOSFET will not be left open at a certain time while switching. So that is the essence of that shutdown resistor. It's making sure that the moment this oscillator stops switching in nanoseconds, it's telling the moment it stops switching, the moment the MOSFET gets closed. So that is the function of that resistor across MOSFET. So in every circuit you are designing, so long a MOSFET is there and it determines the MOSFET switching off immediately the system is off, then it is advisable you connect this resistor. Instead of 22K, you can use just 10K resistor. You can use 10K. Is the widely. Then now the transformer is a center tap 12 volt transformer. Center tap 12 volt transformer. That means from the first side to the middle is 12 volt, and from the middle to the second side is 12 volt. Yes, as you can see. So the output, as you can see, of the transformer, if you check carefully, you will see 220 volt, but you will see a capacitor and a resistor connected across. You can eliminate the resistor there, the 1K resistor 1 watt, remove it from there and connect the capacitor. You can use 0.1 microfarad 400 volt, a non-polarized capacitor, so that it will smoothen the output signal also. Now you can see a fuse at the top right corner, 16 amp fuse. You can use a fuse, but that will be depending on the capacity of the inverter. That is what will determine the fuse you will be using. So I'll also determine how to calculate the capacity while designing an inverter. The capacity you will need, and the capacity you need, how many number of MOSFET, and the size of transformer for each for some capacities and calculations. Now briefly, this is the feedback circuit. So you will need another small transformer, very small transformer, only small 12 volt transformer. You can just get it from the market. I think it should be around 400 or 500, I don't know. You can get it from any store, small transformer. Now the output of the inverter will be connected to this transformer supply 220 from my left, as you can see. So then you connect it to a full bridge rectifier. You can use one N4007, the normal diodes that is very popular. You can use it to make the H bridge. Then put a 10 microfarad capacitor so that it will filter the ripples from this transformer. Then 4.7K resistor, as you can see. Then a 10K variable resistor. You can see the other pin is connected to the 4.7K. So you connect this to pin 1. The sense, you connect it to pin 1, as you can see from this IC. You connect it to the pin 1 of this IC, as you can see sense there. That is the feedback. So you connect it to pin 1, then you'll be adjusting this 10K resistor variable. You will adjust it until it gives you 220 volt on your transformer output. Until it gives you 220 volt on your transformer output, then you stop adjusting. It means your feedback and your voltage is okay. Now thank you very much for watching this video. You can drop your comment, you can leave your questions on the comment section, and please don't forget to subscribe on this video, like this video, and share this video. And I hope this video is very useful to you. Thank you. We'll meet on the next video.